What is up, everybody? It's been a while, and I hate that it's been a while, but I'm gonna make another one, and as always, try to do as many as possible. But I appreciate you guys sticking with me and give me the feedback. I've had a request for this video, and I figured I'd go ahead and just knock it out because it seems to be pretty straightforward and not necessarily related to other engine stuff. So today's going to be automatic transmissions. Get asked this a lot. Basic startup parameters on, how to pick where my shift points need to be and what about the converter lockup and all that stuff. So let's go through it and cover it. First things first, you'd have to actually select that you have an automatic transmission. So where you do that, we need to add a transmission ICF to this tune. So we'll go to Toolbox and add a config transmission, and you can just pick AT transmission, stands for automatic transmission. Alright, toss that in there. Perfect. Okay, so I was going to do one on a 4L80 anyway, but depending on your transmission type, you can go in here and choose whatever transmission that you actually have. If you have a 4L60, the most common gear is going to be a 163 for a second. Not sure that I've ever even done one with a 175, but at least it's in here. So let's pick a 4L80. So one thing to point out here is that the maximum RPM and maximum speed they're not limits. It's just that's where your table's going to stop. So if you're planning on turning 8,000 RPM, just set this to 8,000. If you're going to do 250 miles an hour, go ahead and set this to 250. But it's not like the ECU is going to hit a limiter or anything if you set this to 6,000. It's just this is really setting your axes. I'm going to leave it at 7,200. That's the normal default settings, and it's going to pretty much work just fine for this. Really important right here, the speed calculation is this is everything. The way that your automatic transmission knows when to shift, or the way that Holley knows when to shift your automatic transmission, is based on speed and throttle percentage. So it's using the throttle percentage as load effectively to determine how hard you're trying to accelerate. But obviously the speed is speed. You have to calculate that correctly, and I can't tell you how many times I see this right here put in tire diameter as wheel diameter. If you put 15 or 17 or 18, even 20 in here, it's going to be so far off that you're probably not going to get anything good at all to happen. Most of the time it just overshifts really quick and has horrible bucking problems, and so don't do that. You need to actually calculate your tire diameter. If you don't know how to do that, there's plenty of online calculators and stuff that are easy to do, but effectively, like let's say you have a 275 60 15, pretty common street tire size. 275 is going to be the section width of the tire. So it's not the tread width, but it's how wide the tire is effectively. And the second number is called the aspect ratio. So a 275/60 would be, and this is in millimeters, by the way. So a 275/60, if you multiplied that 0.6, or it's really 60% of the 275 width of the tire, that will give you the sidewall height. So two sidewall heights in metric, and then you convert that to inches and add your rim diameter, and that should give you a rough overall tire diameter. It's a whole lot easier if you actually go out and just measure it with a tape measure. Measure from the ground to the center line of the wheel, because effectively that's going to be a better, closer number to what the tire rollout is going to be, rather than measuring all the way around it. So got a little long-winded there, but let's just say we have a 28. So we got a 28-inch tall tire, and let's say our gear ratio is 373. The reason that this is important and I'm going to click this apply scaling because it's originally this, and I need to apply this to all the tables. So when you apply that, your factor will be 1 again. The reason that that's important is it's going to set all of these tables, shift parameter, line pressure, and our torque converter setup. It's going to set all that stuff along with actually being able to calculate correctly what the speed's going to be. So as far as table configuration stuff goes, just know that you can switch this to map. Typically what I will do for turbo cars is the line pressure scale, I will set that to map. And the reason that I set it to map is because obviously you can have a steady throttle angle with a rising boost curve, and really in that particular case, manifold pressure is kind of more important to not smoke the trans than necessarily TPS. Alright, so let's assume this is a turbo car. It's actually not, but it's just an example tune anyway. Alright, this part is straightforward but has a lot to it. So the first thing that you need to do, I wish that these tables were inverted. You really need to go to your wide open throttle shift points first. Let me explain why. If you look at, let's say we're looking at first, second shifts right here. This black line, that is based on these numbers, that calculates that at 6,000 RPM for the 1.2, that is the black line. And Holley does this because it makes it really easy to adjust on these things if they tell you where basically you're going to run out of engine. So what I always do is go in here and pick a watt shift RPM to start with. And this is a little bit deceiving because you have to go back in and adjust these later, but bear with me, this is going to make a little bit of sense. Okay, so let's say that this engine can turn 7,000 RPM. I'm just going to go ahead and put 7,000 in here for now. So everybody that's freaking out right now because they know that these won't stay, take a deep breath. This is just for getting started. Now, what I'm going to do here is just drag these 2 points up about 7,000. And I'm going to look, okay, 60 miles an hour, I got 10 miles an hour to 60. I want to raise all of this effectively, because I don't want to shift, at 10 miles an hour at low TPS. That's not fast enough for an 80 that's got a really tall gear. So all I'm doing right now, I'm holding control. I highlighted all that. I'm holding control and I'm hitting the right arrow to move everything up. That's not horrible looking. I kind of like the shape of that. I'm going to grab right here and hit smooth. And we'll blend these in pretty decent right there. Okay. And now I'm going to come in here and make the 2 to 1. I'm going to fluff the whole thing just a little, and then I want to bring the top half up just a little bit. Don't want to get overly aggressive on the 2 to 1, or it'll really make the car or truck kind of decel hard when it goes down to first gear. Okay. The other part that I haven't really covered yet is how much converter is going to be in this thing, and obviously that's really hard to cover on an example tune, but we'll talk about that with the converter lockup settings some, but obviously these low speed settings are going to be a lot less sensitive if you have a really loose converter. Okay, same deal with this. We're looking at second to third, and I'm going to grab this whole thing. And keep in mind now, on the first to second, we've got 15 to 20 miles an hour in our cruising, just putting around range. Alright, so let's definitely get at least that more. Grabbing the whole thing, control to the right arrow. It's going to bump the whole thing up. And I'm just going to run it up till, my last little bit here is kind of where I want it. And it's really important that you are going through and making your curves match your actuals, so that even if you're in a situation where TPS does something that you don't want it to do, where it's not reading watt, your speed is going to still push you to the right gear. I like 22 down right here for the downshift because I don't want to get too close to this, but same kind of deal. I'm going to grab the top half, run that up. I'm going to grab just the top third. Run that up too much. Okay, right there. And highlight all this and click the S key to smooth that out. All right, same thing for fourth. Now I want to stress something here. In fourth gear, we don't really want to shift to fourth gear at wide open throttle. So usually I'll come in here and just make this like 199 or something, and that's going to make it where over 60% throttle, and if you're in third gear, it's not going to go to fourth. You don't want it to go to fourth. It's just going to bog. It's overdrive. Bad news bears. But for the sake of setting this curve, I'm going to undo that so that we can do the exact same thing. We're going to go back and look at the 2.3, about 30-ish miles an hour. Third to fourth, going to grab the whole thing, fluff this up to about there. And like I said, I'm going to grab the top, set that to 199. Don't want to make that shift. And we'll smooth this out just a little bit, okay? And same deal. Okay, here's something to watch out for. You don't want your 4 to 3 downshift to overlap your 2 to 3 upshift. Like, that would be bad. It'd be trying to pick a gear one way or the other. Same kind of deal here. I'm going to grab it all and fluff it just a little bit. And it's important to note that this gray line here, that is your 2-3, and it's in there so that you know where it's at, so you can know where to put the shift at. Okay, so here's where we go back to the wide open throttle settings. How do I put this? It takes a certain amount of time to ask for a shift and receive a shift with an electronic transmission. 4L60s are pretty notorious for not wanting to shift. I usually will take 1500 or so RPM out of them relative to where I want them to shift, just to start with, and then go from there, working my way back up. That said, 4L80s are typically not quite as bad, but I've definitely had some doozies. Here's what I'm going to recommend. Wherever you think you want to have the shift at, ask for it 1200 to 15 RPM earlier than that, and you can bias it just a little bit between 1.2 and 2.3. And the reason is because it's really a time problem, not an RPM problem. But the RPM rate of change is so much higher in first to second that you need to give it a running start. Where I'm going with this is, I'm going to say if I want the shift to be at 7,000 RPM, I'm going to ask for it at like, in 1.2, I'm probably going to ask for it at 5,500. This is a safety thing. The 2.3, let's put it at 6,000. And we're not going to do a 3 to 4 wide open, so we're going to put this at something like 8,000. All right, so now this is important. This is what I'm trying to get to. You need to go out and make a 1, 2, 2, 3 log, and look at in the log the moment that it goes, that the gear goes from 1 to 2 and from 2 to 3, and see what RPM that happened at. It should be these, and then see what RPM it gets to before it drops back down to in the next gear. So let's say on our 1.2 it got to 6,600. Okay, if I really want that to be 7,000 and it happened at 6,600, I need to add 400 RPM to this number roughly. And it's not going to be perfect every time, but you got to make sure you aren't ending up in the limiter. So if I add 400 to this, we're going to be at 5,900. And let's say that the 2.3, it only had a 300 RPM swing off. I asked for it at 6,000 and I got it at 6,300. But I really want that at 7,000, so I'm going to set this to 6,700. I would assume in this case that if I want the shift at 7,000, that I'm going to have the limiter be at something like 7,500, and we don't want to get to the limiter. That's the point of this. So anyway, that's how that works. Just want to put that out there. Now, keep in mind that when you do that, your 1.2 here is going to be at 5,900. If you go back to this graph, it's going to be underneath, and that's okay. We want it to be basing shifts off of RPM, we want that to be correct. And the same sort of deal works here, where at a lower TPS, when it gets to whatever that mile per hour is, it's going to ask for the shift. Same kind of deal. It's going to do it early, and that's not a bad thing because it's probably going to need the head start. Line pressure, real quick. I'm just going to be flat honest with you. This is one of those things. This is the default curve. This is not what I would have in here for a turbo car. We're looking at all the boost and before you get the line pressure. So if it's TPS, I'll just show you what this looks like. If you go off of TPS, it looks a little more reasonable, right? At 93%, we've got maximum line pressure. And it's important to note here, too, that this duty cycle, the higher the duty cycle, the more the reduction in line pressure. It's a bypass valve in the transmission. So anyway, like I said, we're doing this is okay from Holley. You can lower this some if you want to for little firmer shifts and stuff. But let's just go in here and do it based on map because I want to show you what you kind of need if you have a turbo car. Wide open throttle for NA would be the equivalent of 95 kPa. So I'm going to put a big 0 right here, and then I'm going to go first to 0 and hit the F key, and that's a fill row values. The rest of them are zeros. I gotta get it to do that. Hang on. 0. Just kidding. Let's try it this way. 0. Okay. Grab the whole thing. I'm doing a Control C. This is how you get it for every gear. Second, put it there. Paste. Third, paste. Fourth, paste. What this does is it makes sure that if you have any boost at all, you have the maximum line pressure on the trans. Okay, here's where the fun begins. Torque converter. The way that this works, I'm going to be honest with you, I usually prefer to have the torque converter activate in third gear. I feel like when it's in fourth, whether it's a 60 or an 80, some other transmissions I really haven't even messed with, but if it's a 60 or an 80, by the time you get to fourth, it's too far. You lean into the torque converter too hard in overdrive to get a really nice soft lockup. Plus, you also have to go really fast in order to get the lockup, which is not good for fuel mileage. So we don't want to do that. Just so you know how everything works, the minimum gear for TCC enable is pretty straightforward. We're going to set that to third in this case. You could set it to first, and if you set the correct lock speeds, it's not going to be a problem. But it's easy to just put it in third to make sure you don't have any overlap. Minimum RPM to enable and disable. This is like a hysteresis mode. This is the minimum RPM that you are going to want it to be locked up. I'm going to tell you 1350 really isn't bad, but let's just put 13 in here even, and then for the sake of actually like getting a little bit of fuel mileage, let's lower this down to 1600. This could be 1200 and 1500. It doesn't even have to have a 300 RPM swing. This is all tunable so that you can make it whatever you want to make it. Maximum TPS. If you want to leave the converter locked up at wide open throttle, you have to set this to 105. It can be 101, 2, 3, 4, 5, whatever. But the reason that Holley lets you set it to 105 and not 106 is because they want to make it where it's allowable for you to be able to max out the TPS. At that point, then you have your TCC disable and unlock for upshift, unlock for downshift. You can have that do that if you really want to. I typically don't use these. If you click TCC disable, it just straight up makes this not work anymore. Your TCC will not, your converter will not lock up. It disables this altogether. You typically don't want to do that if you've set all this up, but in a pinch, if you just are like, you know what, I want to go drag racing and not use this, bam, there you go. Easy peasy. Okay. This part is, I'm going to skip this for just a second. The unlock rate and lock rate is exactly what it looks like. I'm not going to waste your time with that, but basically the way that the way that the clutch is applied, your beginning duty cycle and ending duty cycle needs to be 100. But the beginning duty cycle here is effectively how much you get on the hit, and then lockup time is how long it takes to do that. Same thing for unlock. That's all feel. You're going to have to just go in there and adjust that to your liking. As far as lock and unlock speed, this is something that can be really confusing if you don't have a good solid handle on it, but I'll try to explain this as simple as possible. The way that this works is at 20% throttle and 56 RPM, 56 miles per hour. 20% throttle, 56 miles per hour. If you're in the throttle, you're accelerating up a very mild grade, or even just accelerating out of a turn on a 55 mile an hour highway. At that point, the converter will lock up. If you give it more throttle, let's say you are pulling away from a stop sign pretty hard at 53% throttle. If you stay at 53% throttle, the converter will not lock up until you reach 83 miles per hour, or 84 in this case. All right, so let's see what it's going to take to unlock. If you are at 50, or you're at 84 miles per hour, and you let out of the throttle and start decelerating, so your TPS is now dropped to 0 to a couple percent. As you decelerate, it is going to stay locked up until you get to 39 miles per hour, and then it will unlock. If you are at 50% throttle and you've locked up, and you take it to 73% throttle, it's not going to unlock. You're going to stay locked up because it's at 80. If you go to 80% throttle, it will unlock. And at that point, your RPM is going to jump up. The car is going to accelerate a lot harder. If you are at 89 miles per hour and 60% TPS, and you just locked up and you floor it, you're going to end up right here. So you're going to be unlocked. The only way that you're going to be still locked up, and with these tables right here, if you're still locked up, is if you are at 110 miles an hour and 86% throttle, and it locks up, and then you floor it, it's going to move to the right, and you're going to stay locked up. If you are at wide open throttle, and you're in third gear, and you reach 121 miles an hour, it will lock up. Okay, I think I've kind of covered how the table works well enough. So here's where it gets really interesting. If you have a really loose converter, let's say you got a 4,000 RPM stalled converter, and you pull away from a stop sign or stoplight, or you're going down the interstate. If you accelerate off the on-ramp on the interstate, and you are at 4,000 RPM and 53% throttle, bad example. Let's say you are at 33% throttle. If you're at 33% throttle and 4,000 RPM, and it's totally doable if the converter's loose enough and you're accelerating pretty hard, and you get to 67 miles per hour, which is totally doable to get on the interstate, it's going to lock up really hard. It's going to like jerk your neck because you're at 4,000 RPM, and it's going to drag it down really low. And so that's important because I want to show you this next thing that I made to basically have a tuning tool for torque converters. Works really good for other things, and I really developed it for other things, but it works really good for a torque converter. This is something that if you guys want it, I'm happy to share it, and I will find a way to post it or send it out or do something like that. But I'm going to click over to an Excel spreadsheet real quick. and this is just something I made for, this is a 4L80 gear ratios. I have one for a 4L60. I have one for T56. You can do this. You can input these gear ratios if you have weird ratios for some reason. So let's just put in here what we've got. I said a 275 60, 275 60, 15, and a gear ratio of 373. So basically, it does all the math for you here. If you put this in right here, it tells you the theoretical diameter, tells you what the rollout's going to be in feet, and the width is backed out of the 275. Here's where it gets important. Gear 3, that's where we're doing our lockup, right? So if you have a 4,000 RPM stall converter, if you look at the 4,000 RPM column, that thing's going to be doing 89 miles an hour whenever it's 1-to-1. Whenever your engine speed and your input shaft speed are the same, you're going to be up doing a ton of RPM and mile per hour. So the way you need to think about this is, what is the number? Where am I going to be at where I'm at 2,000-ish RPM and I think that I'm going to, want it to lock up there at very low throttle? What amount of throttle with my converter do I honestly think will be 2 to 2,500 RPM? 2 to 2,500 is going to be in the 45 to 55 range. Call it 50. Let's say that's going to be, I don't know, 20% throttle. This is obviously got some subjectivity to it. At 20% throttle, I'm looking here at 56 miles per hour, which actually is pretty darn close. This would work out pretty good for our little experiment. But I really wanted 50, right? So I'm going to come in here and I'm just going to grab the whole thing to start with and drop that down. 20% throttle, 50. Okay. We've dropped the whole thing. Now let's look up here at wide open throttle. Let's say I want to grab the converter 5,500. It's 122. Watch this just work out totally and make me look silly. Okay, all right, look. A little bit different at least. So we're going to run that back up to 122, 23. Okay. And I'm going to grab these, do a fill row values. Okay. So there's our curve. Let's see what this looks like now. So 60% throttle is not going to lock up until 86 miles per hour. 86 miles per hour is going to land in the perfect. Yeah, it's going to land in the 3750 to 4,000 range. It's going to be right up there near our converter. Okay. The way that this is going to work too is kind of like a downshift. This converters are really weird because it's almost like having a little bit of a gear change, but it's not. You got to be careful with it. The question is, at this point, as I'm coasting down, at what point do I want to come out of lock? We were at 50. 39 is actually probably not that bad. I'm going to run it down just a little bit more to make sure that we're not constantly going, in and out of lock and unlock. So let's say we're down here. We'll make that 33 for my OCD. And yeah, that's not bad. You can come in here and manually kind of, adjust some of these and make that curve look like what you want. Okay. Here's the next kicker. Remember what I said about having a locked converter at wide open throttle? So if we go back to TCC parameters, we've got our minimum set to 105. But the problem is, I'm telling this thing I don't want to lock up until, at wide open throttle, 123 miles per hour. We don't want that. So what you actually have to do is go in here and say, if that's the case, when do I actually want it to lock up? When would I want that happen? So I'm at wide open throttle. I've jumped to 4,000 RPM because I have a 4,000 RPM converter. And I'm running up through my gear. And let's say at about 6,000 RPM, I want this thing to grab a gear. Say 5,500. There's that 122 that we picked earlier. So 5,500 RPM, I want it to lock the converter up. It's going to drag the thing down a little bit and then just keep right on digging. What I'm going to do here is at 93% throttle, there's 117. Usually right here is where I try to draw these out. So what we can actually do, let's set this to 122. And we'll do a fill row right here. At this point right here, you need to set these to less than this, right? We want it to, when it gets to that point, go ahead and grab that gear. So we'll set it to 120. So basically at 120 miles per hour in third gear, should be about 5,300 RPM. And it's going to grab that gear. Now, the other part of this is you don't want it to do any kind of downshift weird. So I usually will do the exact same thing. I'll flatline this off just to make sure that it doesn't do anything funky. But as long as you are going to be over that mile per hour, then you should be good. The only way that it's going to downshift at that point is, let's see, you got down to 77 miles per hour at 100% throttle. You're going up a pretty steep hill with a weak engine if that's what's going on. You can also do this a little earlier. Like say you wanted to do it right here. Pull that down underneath. And you're effectively just setting wherever you're going to lock the converter at whatever throttle you're going to lock it at. What I wouldn't necessarily do is have this scenario. And the reason I say that is because if you were to roll into the throttle at 73% or 75% and you're still fighting traction or something, I don't know why you'd fight traction to 120 miles an hour, but hopefully this makes the point. You wouldn't want to then give it more throttle and then it just yank a bunch of speed out of it. That wouldn't make a whole lot of sense. Okay, I think I've covered that pretty well. Like I said, if you guys have any questions and want a copy of this spreadsheet here to be able to look and see what your one-to-one speed is going to be at a given RPM and a given gear, just let me know in the comments and I'll try to make that available somewhere, either on my Facebook page or post it to the video, or I'm not really good with that stuff, but we'll figure it out. And in the meantime, shoot me some comments or questions, hit the like and subscribe, all that good stuff that I'm supposed to ask for, and let me know if there's anything else you want me to cover that would be helpful for setting up transmissions. Just so you guys know, it's pretty common to see something like this. And the unlock needs to be something kind of following that. And we're going to have a curve like that is going to be more indicative of setting our TCC parameters here. We'll set that to 50 or 60 to say we did something different. In that case, over 60% throttle will be unlocked. All right, I think that's pretty much covers transmissions. They're not too horrible. The biggest thing that I want to emphasize is definitely when you're setting these watt shift RPMs, just make sure you put some buffer in there at least to start with and slowly fine tune them to be what you want them to be. All right, catch you guys on the next one and look forward to getting some feedback. Have a good one.